Hi, welcome to part 2 of this video on application modernization. I'm Raghuvir Varhagri and this is Hands-on AWS. In the earlier video, we talked about the various strategies for migrating to the cloud and talked about rehost and refactor as two alternatives. And we talked about monolith applications specifically and the couple of alternatives to modernize those monolith applications into microservices architecture, one of them being rehost first and then iteratively modernize, and the other one being refactor, namely modernize those applications as part of the migration journey. We talked about the advantages of doing rehost first and modernize later, and talked about a particular pattern of modernizing a monolith application through a couple of intermediate steps, namely using the facade pattern and the triangular pattern. So we will dive into a demo on the same pattern today with a particular example of a monolith application that starts out with a three-tier architecture with the middle layer being a single monolith Java Spring Boot application on an EC2 instance, and we will end the demo with a fully microservices architecture based application where the application layer has been replaced with an API gateway and a set of Lambda serverless functions, and the database has been replaced with DynamoDB NoSQL database. We're walking through the Iterative App Modernization workshop. We are using the event engine today, and we have logged into the console. The first step is to verify the backend after deployment. So we'll go to the cloud formation stack that has been deployed by event engine and look at the outputs. So we have the public DNS for the compute backend, and we have a bucket that is hosting the static website. So we'll take a look at the backend and make sure that it is working fine. We will hit the unicorns endpoint, which will respond with a list of all products in this unicorn shop. We have about 10 unicorns listed with their UUIDs, which will be useful in the subsequent part of the demo. So the next step is to make sure the front end is deployed correctly and working fine. So in S3, this is the UI bucket that is configured as a static website. If you look at the properties, this has been configured as a static website enabled, and this is the endpoint. So when this CloudFormation template is first provisioned, the config.json is provisioned with a placeholder endpoint. So if you download this and then open it in your local editor, you will then be able to replace the host inside the JSON file to point to the application backend. So let me quickly pull it up. Config.json, here it is. So we have used this public DNS of the application backend, which is an EC2 instance at this time. We have plugged it into this host value and saved the JSON. And we have uploaded it to this bucket. I have already finished that. So once I upload it here, you will be able to hit the endpoint of the bucket and see that the application is up and running. So here is our unicorn shop, and these are the products listed. So if you did not have your configuration updated correctly in config.json, while the page would load, none of the products would load because these products are being retrieved by hitting the application endpoint, which we just tested here. And then the application displays them on the front end for users to purchase. So another thing we can do to make sure that this is working correctly is to open the developer console by hitting the F12 key, keeping the console open, and then clicking on sign up and just entering sign up, and you'll see that a UUID is generated for that user with this email, and you can make a note of this for later reference. All right, now we will move on to the next step. So we've already done all this. So we noted down the UUID of the user that we have just signed up as, which is js@unicorn.com. All right, now we'll move on to the API gateway step. All right, we'll head over to the API gateway service now. So far what we have done is verified that the Monolith application is deployed and working correctly. So we'll start with the application modernization in steps, including the following this triangular pattern. So the first step there is to create an API facade that will provide a front end for the users to access the same Monolith application but through an API interface. So that will set the stage for us to do changes behind the scenes and move one service at a time out of the monolith pattern and separate them as a separate service, microservice, without impacting the user experience. So it will be all transparent to the users when we change how that service is handled behind the API gateway. So the first step for that would be to create an API gateway and create the methods and services that handle all the various functionalities of the front end. So we'll create an REST API first. Okay. It's a new API. We will call it unicorns, edge optimized endpoint, and create API. And once this is created, we will create a couple of methods under it. We'll first create a couple of resources. The first one is unicorns. We'll always enable CORS for cross origin resource sharing. Under this, we will create another resource called basket. Remember to enable CORS for everything. Under the root, create another resource named users. Sorry, this should be user, not users. So we'll delete this. Delete resource, delete, then we'll recreate that. User, under that we'll create another sub resource for login functionality. Under basket, you create a resource for the individual item using the key Uuid. Use the same curly braces here as well. Create resource. Now we'll create a couple of post methods for user and user login. Post, and we'll select HTTP post. The endpoint URL would be this, followed by user. Rest should be same. Click on save. Another post method here. Create method. HTTP / user / login. Defaults. Now let's test this. First, this post method. Let's test with email, first name and last name should be the payload. Here is the template for the request body. Replace it with any other email address. Let's say xyz@abc.com. It can be anything really. When we test this, we should receive a 200 OK response with the UUID in the body. So we will copy that. We can use that later. Now we'll test the login method. We can use just the email address for login. There's no security here really because it's just a proof of concept. So here you could paste xyz@abc.com, which should be a valid user ID. Test it. So yes, you got a 200 OK response with the UUID of the user. This matches what was just created a few minutes ago. So we are good with the user and login methods. Now similarly we'll create the unicorn and methods under it. Okay, we'll start creating the methods under unicorns now. Create method, this will be a get method. HTTP, we take this endpoint. This is the domain name followed by unicorns. Nothing else is required. So if we test this, we don't need to provide a payload. Just test 200. Okay, so with a bunch of unicorn product it is returned, so that is good. The basket, we'll create a method for the basket. It will be a post method. post HTTP, again domain name, same unicorns/basket. Nothing else needs to change. So this one is to add a specific unicorn to the basket. So here we'll need to create a UUID to test this, as well as use a UUID from this to add to the basket. So let's see, the first one is unicorn float and UUID ending in 17. So to test this, we'll go to the request body and paste the template. So we will take the first UUID and paste it into the list that we want added, and this will be the UUID of the basket. It will be saved in DynamoDB. Maybe we'll randomize it. Test. There's no response body, which is fine. We will configure a delete method as well to delete items from the basket. So basket delete. All right. This needs the same endpoint. Domain, sorry, not this one. Copy this, paste it here, /unicorn/basket. Everything else remains the same. We can test this. This is what we tested. So we'll copy this. And we'll paste this unicorn that we want to remove from the basket. I believe we randomized this one. What did we say? 5. Okay, 200 response, which is okay. Now finally we'll create a get method for UUID sub-resource. Once again it will be HTTP. We'll get the DNS name from here once again. The path will be unicorn/basket/ the parameter UUID. This should be good. Alright, if you want to test this, we will need the UUID of the user. So let's get it from Mr. XYZ. Alright, 200, okay. We don't have any unicorns here. In this basket. Okay, if we want to properly test it, the post method under the basket resource, the payload format that you have, this is not random. This is the UUID of the user, and this is the item that you want to add to their basket. So let's do it properly this time. So let's say I have the first user ID that we created, Mr. JS at unicorn.com, in their basket. Let's put the first unicorn. Okay, 200. Let's also put one of these unicorns. So we have unicorn float and unicorn beddings going into Mr. JS at unicorn.com's cart. What happened? B17. Yep, this is a different one. Just looks very similar, that's all. All right. So let's try to get the basket for the same user, which is this one. And if we pass the UUID for this user, unicorn float and unicorn beddings. So these are the two items that we added to the basket as this user, and we are able to retrieve them. So the methods are working fine in test, so we are ready to deploy them. So the dashboard should look like this. You have unicorns slash basket, you have unicorns slash get, delete, post under basket, and get under UUID. For users, you have post. For creating user, for login, you have post. For logging in as a given user. So we will deploy the API and then connect the UI to this newly deployed API instead of the existing backend, which is directly coming from the EC2. So now, all right, let's deploy our API now. Before we do that, let's make sure we enable cores on all our resources and methods, because without that, the site will not work. Every time we modify it, we will have to enable cores. Right. Now we are ready to deploy this top level method, deploy API. Let's call it dev. These are optional and we deploy. So now you have a invoke URL with HTTPS. So let's copy that and test it out. Let's say call the unicorns get method. It seems to be working. So now we are ready to go back to our S3. and update the config.json. So instead of the front end pointing to the EC2 instance, it will connect to the API gateway. Once we update the config.json here, so we'll go back to config.json. Here we'll paste the API gateway's dev endpoint and save this. I'll come here, upload, drag and drop this file. Config.json, permissions, grant public read. I understand. All right, we have updated the configuration. So let's see if we are able to. Seems to be working. We can do a Control F5 to do a cache refresh. Still working. That's good. So far we have created the facade API using API gateway and then pointed the front end to use the facade API. So we are now free to do whatever we want on the back end. And as long as we keep the services available through the API gateway, irrespective of the implementation behind the scenes, whether it is Monolith or microservices, the users should still be able to access the same functionality. So now we'll work on separating out some of those services in a straggler pattern. Now we will replace some of the functionality on the backend using serverless and micro containers. We will use Lambda as an alternative for compute triggered by API gateway, and those Lambda functions instead, in turn, will use DynamoDB for persistent storage. It's a serverless key value pair storage that AWS offers. So let's get started by creating first a DynamoDB table. Going to DynamoDB interface and click on create table. Create table. Let's give it a name. Call it Unishop. Primary key or partition key should be Uuid. We will use this for maintaining the cart. Let's click on create. Okay, as is provisioning, let's create a role for Lambda to use. We'll go to IAM. Create a role. The type of role we'll create is a service role that will be used by Lambda. And in the permission section, we'll search for a AWS managed policy instead of creating a new one. No tags are required, so we'll give it a name. Let's call it mono to micro, as in monolith to microservices, Lambda role. That's the demo we are following. And that's it. We'll create this role. And we are done. Let's take a look at the role that we just created. and the permissions that we have given. So this one currently only has CloudWatch logs. We'll need to grant additional permissions to this. For the Lambda function to be able to read and write the Dynamo table, we will have to grant those permissions here. We'll use item, put item, delete item, update item, query, scan. And we want to grant least privilege, so it will be for a specific resource for a table ARN, and the table name should be created by now. Unishop. Amazon resource name is Unishop. So we can paste it here. Oops. And we are ready to update this role. This is the inline policy we are adding. Okay. Yes, I ended up creating customer managed policy instead of inline. That's fine. It has the same effect. This is the final policy. We could also have applied the same policy as inline policy. All right, let's move on. So we will now deploy Lambda code and instruct the API gateway to invoke this newly deployed Lambda for shopping cart functionality. Okay, let's log in as John Smith. Look at the cart. Unicorn float and unicorn beddings are the items that we had programmatically added to this cart when we were testing the API methods that we created using the API Gateway console. Now we will head over to the Lambda console. We will create a new function. The functionality required for this method has been made available through this workshop, and it is available in the other bucket. So if we go to look at all buckets, there is an asset bucket. There is a jar file here. We will download this to our local machine. We'll upload it to Lambda when we create the function. So let's create a new Lambda function from scratch. We will give it a name, add unicorn to basket, because we're trying to replicate the shopping cart functionality and bring that functionality out of the monolith. Let's take the latest Java version, permissions, use an existing role. We can use this one. We can create the function. Once it is created, you can upload a zip or jar file. You can upload from the local machine. I think this did not get downloaded. Let me keep this. Now the download is complete. We should be able to upload. Yep. This is the jar file which we downloaded. We'll upload this and save. So now there is a new way we can directly provide those directly from S3, but this should still work. Alright, successfully updated, uploaded. To edit the handler, replace this placeholder text with the specific handler that we have in our jar file and save it. So when this Lambda function is invoked, it will know which method within the jar file to invoke. We can configure a test. We'll create a new event called add unicorn to basket. We will use this payload pattern. If we test with this, we haven't replaced the example Uuid, so we might see an error. Let's see. Okay, I think there's no validation at this time. Okay, so this would have tried to insert. Here you go. This was inserted. This UUID was inserted under this partition key. Alright, so this Lambda function seems to be working fine. Similarly, we will create a function for remove unicorn from the basket. Create a function, remove unicorn from basket, Java 11, default execution role will be an existing role. Create function, upload the code. Runtime is fine. The handler needs to be updated to this. Remove unicorn from basket. Finally, we'll create one more function for get unicorns basket. This would be Java 11 again. Permissions, existing role, create function. We'll upload the source again. In reality, you might have different jar files for different functions, but for simplicity, for this demo, we have a single jar file that has all these functionalities in a single jar file. We are ready to update the handler function for this get unicorns basket as well. And once we're done, we can actually test this one out. We can call this event get unicorn basket and use the same example Uuid we used to create the basket in the DynamoDB table and test it. If it works fine, if we did everything right, we should get a response with the contents of the basket that we just created. So you should see this basket returned with this Uuid. Let's see, 26297. 26297. Okay, so our methods are working fine. Let's move on to see how we can integrate these Lambda functions with the API gateway function calls. Now let's start integrating these Lambda functions with API gateway. So let's go back to the API gateway console, then the unicorns API. Let's look at the shopping cart. So you have the basket, we have add unicorns to basket, remove unicorns from basket, and get unicorns basket. Those are the three Lambda functions we have created. So those correspond to these methods that we have here. So let's first work on the slash unicorn slash basket resource and the post method there. Let's go to the integration request, switch from the HTTP pointing directly to the EC2 instance to Lambda function that we just created. The Lambda region that we have is US East 1, North Virginia, and the Lambda function should be add unicorn to basket. And there is nothing else to select. We save this, accept this warning. You're about to give API gateway permissions to invoke this Lambda. So yes. Okay, this is done. So we can go back to the method execution and test this. Let's see if we are able to test it using our placeholder UUIDs that we already used. So this time this API method is not hitting the EC2 application service directly. In fact, it's not even touching that existing monolith application. It is invoking the Lambda function and trying to call the Lambda function that adds this to the DynamoDB bucket that is implementing the shopping cart. So I think let's use a different unicorn. We are getting a message saying that unicorn is already in the basket. Apparently, we can only add one of each as API gateway. So let's do the same UUID of the basket. Let's add a different unicorn. Added unicorn to the basket. I think we should randomize this. That way we will not have any collisions later or invalid UUIDs when we try to retrieve it. So let me save this to our notebook. All right. In fact, we can go to the Dynamo table and refresh this. View items. Okay, we have multiple items here. I think we'll once again use the correct one, not a randomized UUID, but we'll use the one for js@unicorn.com. We'll add these items to the basket for this user. So let's try that. Click on test. Okay, we are seeing added unicorn to the basket. Let's see if we can find it. Okay, we still have the original item. Okay, I just had to refresh the page and we can see all the items that we added through our Lambda method. So this was the randomized UUID you used. And this one, if I believe, uh, is the UUID for js@unicorn.com 46D. So this should be visible from the front end if we log in as js@unicorn.com. We'll test that shortly. So this UUID should correspond to the first item in the list of unicorns, B17 unicorn float. We will repeat the same steps to create the delete method in Lambda. So the Lambda is already created. In the API gateway for delete, we will update this from HTTP to Lambda. We'll go to US East 1, select remove unicorn from basket, and that's it. Save. Okay. Once this is done, we should be able to test it with the same payload. So for JS at unicorn.com, we are removing the first item from the basket. Unicorn was removed and basket was deleted. So if we refresh this, this should be gone. It will take some time. There you go. I think I am having to refresh the browser. This refresh does not seem to be reloading for some reason. Okay, now the third method remains, which is the get unicorn method based on the UUID. Here, in order to switch from HTTP to Lambda, we will have to create a mapping to pass on the UUID to the Lambda method correctly. So we will go to models and create a new one. The model schema that we will use is this. We will call it unicorn basket model. The content type would be application/JSON. And we can create this model. Now we can navigate back to the APIs and the get method that we're talking about. Unicorn basket, this one. Now we can change the integration request type to Lambda. We'll save this. Mapping templates. Okay, we need to replace it with this provided piece of mapping. So once it is saved, we can go back to test this. I guess we need to provide the UUID as the parameter before testing. So we got a null response. Let's get the UUID. For js@unicorn.com. I think currently they would have a blank basket. So we're going to post an item to basket once again. Okay, added unicorn to basket. This is B17, which is the first one. That is unicorn float. Let us add the last one as well, which is unicorn fluffy. This is also B17, so slightly similar Uuid is there. Let's add one more item to basket. Okay, two items added to basket. That should be unicorn float and unicorn fluffy. Let's check by refreshing this page. 46D, Mr. JS, two items, B17, B17. All right, now let's test our new get method by passing this user's UUID as a parameter. Excellent. We got both these two items that we just added in response, so we are good. Before we redeploy the API, we have to enable cores on all the unicorn resources once again. Enable cores, same thing. We can deploy API once again. We can deploy it to the same stage. So the URL has not changed. So for the users, it should be transparent. So if we go back and do a hard refresh, logged in, it says. But nothing in the cart. Let's see. Login. I think we have not implemented the login method. We'll do a hard refresh of this page. Okay, it looks like we are having a course policy issue. So we must have missed enabling course on one of these resources. So let's go back to our API and enable course again. We may have missed the course enabling on this item. Sorry, I was missing this step. Sometimes you just do it blindly. All right. Now, if we deploy this API root level to the same dev stage, it should have the same UI URL, and do a control F5 to do a hard refresh of this page. Still getting course policy. Let's see. I think see any errors here. I think the browser is not refreshing. It's still using the old config.json, I believe. Let's see. Login as okay. Unicorn float and unicorn fluffy. These are the ones that we added to the cart programmatically, so we can see them in the cart. So far so good. If you face this issue, try using an incognito window or a different browser. And remember to enable the course correctly. I was doing it wrong, as you could see. So when you enable course, you get an option to confirm to replace the headers, and you have to click accept and replace the headers. All right. So we went through a bunch of steps. We started with a monolith application and then replaced the facade or the interface between the front end and the back end of the application using an API gateway as an intermediary that allowed us to start doing this straggler pattern by extracting out small functionalities from the original monolith application and start implementing them through serverless and micro containers instead of implementing it as a monolith. So once you have those services implemented, you can switch the API gateway to invoke those services instead of the monolith for that specific function call from the front end. So we demonstrated that successfully using just the shopping cart functionality, for which we implemented three different Lambda functions implemented in Java and backed by a DynamoDB database instead of whatever database was being used by the EC2 instance. So once we do that for all of the core functionalities and the remaining functionalities of the original monolith, there would be nothing left in the monolith application to invoke from the API gateway. So you can retire that monolith application and you would have completed your journey of modernizing your monolith application to a microservices based architecture.